So welcome at Ask a Professor for the MOOC Railway in Integral Approach. I really like to have these questions because you learn something, but also me. I learn a lot what you have in mind and what to do with your questions. So please do this during this MOOC and feel free to ask me as much as you like. I really appreciate it. So question number one we have now at the moment for Ask a Professor. I'm really like to explain, and hopefully it is useful. The question is passengers or freight? What is the most valuable, and are they valuable for transport and using the railway systems? I think it's both very valuable, because when you compare, for example, passengers, when they like to travel and you look at the airport, then you see that only a few hundred passengers can go into the in the airplane. And when you compare that to the train, then you have really mass transport, because more than 1,200 people can enter a train. So when you look at China, for example, they also have a connection by high-speed lines, and that's very efficient and valuable, because you can also travel from city center to city center. For the freight trains is also valuable because it is mass transport, and mass transport is what we need, and also what we have to do when we compare that to CO2 reduction. Another question of Ask the Professor is about friction on tracks. And what I understand from my question is, what is the reason that we stepped on rail for steel, so steel wheels and steel rails, and what about traction control, and what happens with the steel and the steel structure when you drive over? It's a very good question, I think, and also a very actual topic, because a lot of problems we see now is, for example, the defects we have with modern trains because of traction control. And I think the best way is to show you how this works on our rail here in our laboratory. We see and we can just jump in without any safety regulations, and that's what I like, of course. For example, here we have tracks, and when you have a wheel and the wheel is just running over it, then you can see that it is just running over and rolling over, you could say. But the other way is when you are sliding or slipping, then you can also see this. And when this is happening, it is just slipping around, and then it could be a traction control, and that could be a reason why you can have high heat input just on this spot when you look at this rail. And when you look at this rail, you could see that there are some flat spots, for example, when it is a slippery track, but when you have traction control, the wheels are just running over and over again, and then you get a hole, you could say, on the running band of the rail. And that could be a difference of heat input, and that can cause defects. Another question of Ask the Professor, I like to answer that also here in our laboratory of TU Delft, where we have some tracks where we can explain without any safety regulations, and that's what really helpful to give you some answers. And I can also show to you. So another question was metallurgical properties of rails, and will there a discussion on the metallurgical properties of rails? And I think there is. And when you see now what is really the discussion is, when you look at a wheel rail, let's look a wheel like this, and when you see this and you put it on the rail, it looks very easy and very small, and it is really small, and that's why it is so high stress and strain inside the steel. I also have an euro, and that's more or less the contact patch we have with the wheel and rail. There's only 1 euro here on the spot, so you can imagine that the stress is really high, and also has to be carried through the rail on the head of the rail. Therefore you need head hardened rails, high carbon percentage, till 0.8, to have this high resistance of wear, but also to carry and to catch the load. And mostly there is no problem when there are coaches can say, okay, I cannot carry the load. It is more or less about how can I go on with the load and when do I get defects. So the balance is where or stresses like cracks, and when. So welcome outside here at the TU Delft campus at the Green Village, where we also explore and then also use all kind of new ways of durability and CO2 reduction and new styles of energy savings. So I think that's also a nice place where we also have our first prototype from the Hyperloop. You see here a pipeline in scale just to do some tests. And later on this MOOC in week 6 you will see how this Hyperloop looks like, how it works, and also other future transport systems. I think it's really challenging and also futuristic. But now I like to show you, because I have a question about maglev trains. And maglev trains seems to have only benefits, except the cost, of course. Why are they used so rarely in commercial traffic around the world? And I think there's only exactly what you say in your question. It's about the costs. Because the costs of new transport, you have to build new infrastructures. New infrastructures means a lot of money per kilometer, and you need a lot of kilometers. So the best way is to have a transition technology, so you don't have to use a new way of infrastructures, and you only have to use the first way of just to use the old way and make a transition of that one. So making a pipeline, it works maybe fine, good structure, it's easy, high speeds, but you have to pay for that. And that's exactly with maglev. There is the electricity and the magnetic field. That's why you're floating on the magnetic field, and you have to create that, and that's inside the infrastructure. And that makes a lot of costs. So that's it for this week. Thank you very much for listening, and also especially for your questions. So keep the mood high, go on, and please send me new questions, because on 2 weeks from now I will be back for the next session of Ask the Professor. Thank you.